Hello, welcome back. This is number 23 in my Fog of War series. This one's a bit similar to the ones that I've done the last few, where the fog opens up a bit differently. So don't be worried if you put a number in and the fog doesn't open up around it. It will open up in sections when you get the right numbers. It's possibly a little bit harder than the last one, but once you get going and if you remember to use the rule, which I'll tell you in a minute, throughout the whole puzzle, that will make it a bit easier. The ending's a little bit harder in this one, in that you have to do just some normal Sudoku work, which is a bit harder than the normal cryptic ones where there's lots of clues. I did originally have more clues in this one, and I thought, oh, you don't really need them, given the last rule here. So I'll just go through the rules with you. First off, normal Sudoku rules apply. Cells adjacent to an x add to 10. So if we have an x in that line there, these two next to it have to add to 10. Black dots separate cells in the ratio 1 to 2. That has to be a 1, 2 or a 2, 4 or something like that, where one is twice the other one. Cells on pink Renban lines are a group of consecutive numbers in any order on the line. So these ones here, for example, that one, that one, that one, has to be consecutive with the 4. So you could have 2, 3, 4, you could have 4, 5, 6, you know, 5, 4, 6, or any order whatsoever, as long as they're consecutive numbers. The 7 has to be, for example, 5, 6, 7, or 7, 8, 9, 8, 7, 9, 8, 9, 7, as long as they're 3 consecutive numbers, but in any order. Adjacent cells on a green German whisper line must differ by at least 5. So this line here, if that's a 1, it has to be, the next one along has to be at least 5 away, so that has to be a 6, 7, 8, or 9. And then if that, for example, was a 9, the next one along would have to be at least 5 away from a 9. So it could be a 1, 2, 3, or 4. If that was a 6, the only thing 5 away from a 6 would be a 1, for example. So actually you couldn't have a 6 there because you'd have to have a 1 there and there, which is not possible. 7, you can have a 1 or a 2 next to, etc. Cells on a grey sequence line must be the same amount apart and in order. Now, I've used some examples there. Something I noticed, I've put all the examples in order going forwards. They can go backwards or forwards. Obviously, you can have 1, 4, well, not 7 in this case, but 1, 4, 7. You can have 1, 4, 7 going backwards. They can go either way. But they have to be the same amount apart. So they can jump up by 2. So you can have 1, 3, 5. They can jump up by 4. You can have 1, 4, 1, 5, sorry, 1, 5, 9. They can't jump up by 5 because that would be too big, but as long as they're the same distance apart on that line, and these ones have to be in order. Now this new rule that I've included, I haven't done one of these before, but it made for a quite interesting puzzle. All orthogonally adjacent cells cannot contain consecutive numbers. So orthogonally adjacent, orthogonally is straight next to each other, like those two, and those two are next to the 4. Now they cannot contain consecutive, so if that's a 4, consecutive to a 4 is a 3 or a 5. So that means these 4 cells here can't contain a 3 or a 5, so they have to be in the corner ones. With the 7, you can have 6 or an 8 is consecutive to a 7, so the 6s and 8s all have to go in the corner in this one. And that rule there, I'm just giving you a clue, you need to use that quite a lot towards the end to resolve the puzzle, and throughout the whole puzzle that rule comes into play, so don't forget about that one when you're working out the Sudoku. That's about all you need to know. There's a link in the description below as usual to have a go at it yourself, and if you get stuck you can come back and watch the solution, which I shall go through now. So to start with, these Renban lines, that can go down as far as 5, 6, 7, so that could be 5, 6, 5, 6, or it could be up as far as 7, 8, 9, so that could be an 8, 9 as well. Now there's a dot there, so that can't be a 5 or a 9, because you can't have a 2 to 1 with a 5 or a 9, so that means 6 has to be a 3, 8 has to be a 4. Okay, I'll go up to this one now. So this one can go 2, 3, 4, or 4, 5, 6. Now what can we work out with those? If that's a 6, 3, That would leave over here 2, 4, 5, which are not consecutive numbers. So that says that can't be a 6, 3. That's got to be an 8, 4. That's not an 8 then. And now we can't have 5, 6, 7, so that's not a 5. That's a 6 or a 9. It doesn't affect this in any way just yet. Can't tell what goes on there yet. We'll have a look at this sequence line over here. Now, with the 7, the 6 and the 8 can't go there, there, or there. I've already got the 8. That means there's a 6 there, there, or there. So I'll see if a 6 can go on the sequence line. If that's a 6, you can't have 7, 8, 9 now, and you can't have 8 because the next one will be 10. So because we can't have consecutive numbers, the sequence line is going to have to go up or down by at least 2. So down by 2 would be 4, which you can't have. Down by 3 would be 3, and then 0, which you can't have. And the same reverse way around. So that can't be a 6, and that can't be a 6. So that means this one has to be a 6. That gets rid of that 6. And now we're left with 1, I'll put them all in here I guess. 1, 3, 5, 9, what have I missed? A 2. A 2, there we go. Is that the best way to do it? Might be better to put them one at a time and see what we can have. We can have, oh, I can probably see from there. We can have 1, 3, 5, 1, 3, 5 going that way and that way. 2, I don't think we'll go with anything. You can't have 2, 3, you can't have 2, 5 because it would have to be 7. So that can't be a 2. And you can't have 1, 2, 3 because they're consecutive. So you can't have a 2 there. That means there's either a 2 here or here. Can't have a 1 in the middle because they have to go in order. So the 1 couldn't possibly be in the middle. And the 9 couldn't be in the middle. But it could go 1, 3, 5, 1, 3, 5, or 1, 5, 9, 1, 5, 9. So that means there's either a 1 or a 5, whoopsie, that one there I meant to put in, a 1 or a 5 there. And the 9 and the 3 are optional, they could go here or here. So that can't be a 1 or a 5. And that's not a 1 or a 5. I don't think I can get it down any further than that at this stage, but hopefully this might tell us what goes over here. That can't be a 1, 5 there. In fact, if you can't have a 5 there, you can't have a 5 next to the 4. One of these is definitely a 5. So that means that has to be a 3, 4, 5, not a 2. So that can get rid of the 2's there. Now 2 can't go there or there. There's definitely a 2 up there somewhere. And the 5's there. What about the 1? The 1 could go anywhere depending on where that 2 is at this stage. Alright, so let's have a look at this German whisper line. What can we have on that? So if that's a 3 and a 5, there's either a 3 there or there. So I've got a 3 and a 4. So if these were the little ones on the German whisper line, you can't have a 2 because of those ones. You can't have a 3 or a 4. They'd have to both be 1s, which you can't have. So that means these must be the big ones. So they have to be 6, 7, 8, not 7, 6, 8 or 9. That one there can't be a 3, 4. That can't be a 1. That one's got to be a 2. Now that gets rid of that. And then these have to be big. They can't be a 6 with a 2, so they have to be an 8 or a 9. And now we've got 1, 6, 7 left. The 1 can't go next to the 2, so that's a 1 there. And that's revealed the fog, and we have a 6, 7 pair left there. And now because it's an 8, 9 pair, that one's not a 9, which means that's definitely a 9, so that means that's a 1, 5, 9. And I can get rid of the 3's up there. That one, get rid of the 3's, and I guess I'll get rid of these things up the top here now. We don't need those to see what's happening now because they're all in the boxes. So that's definitely a 5 because it's got to be 1, 5, 9 or 1, 5, 9 either way. Gets rid of the 5. And now we've got to work on these ones. What do we have here? So this one's not only got to be a 2 times each other, but it's got to be a sequence line. So we can't have 1, 2 because they're consecutive. We could have 2, 4, and then 6. We could have 3, 6, and then 9. We can't have 4, 8 because that would be up to 12, and that's all you can have. Oh, can it go the other way? Can we have 6, 3, 9? I was thinking, yeah, we can't have 9, 3, 6. It can't go that way. 9, 6, 3. Sorry. Could we have 6? We can't have 6, 4, 2 going the other way. No. And you can't have 6, 3 because that would be down to 0. So I think that's the only options there. You can't have a 4 because 4, 2 would be 0 and 4, 8 would go up to 12. So they're the only options on there. So now this green band line here, the maximum it can go to if that's a 3 is 4, 5, 6. And there's a 6 there no matter which one that is. So it can only be 1, 2, 3, 4 or 5 on these ones. If that's a 2 it's 4, 6. If it's a 3 it's 6, 9. So either way there's a 6 there. Now if that's 2, 4, 6, that 4 ruins the what do you call it, the consecutive numbers here. You can't have 1, 2, 3, 5 going around there because they wouldn't be consecutive. It's 1, 2, 3 would be the most you could have, so that can't be a 4, or this doesn't work. So that has to be a 6, which means that's got to be a 3. And that has to be a 6, and that's a 9. And then these would be either 1, 2, 3, 4, or 2, 3, 4, 5 around there. Okay, now I don't see that we can get much on that at this stage because there's nothing to go off. We'll put these ones in the middle here and maybe that will help. So 2, I've got 1, 2, 3, 4, 5, 6. It's going to be 2, 7, 9. That one's not a 9. Now this is where this all the orthogonal adjacent cells cannot be consecutive numbers will come into play. So a 6 can't go next to a 7, so that can't be a 7. There's nothing there that we can eliminate. A 2 can't go next to a 3, so that one is a 7. That's not a 7. We've got a 2, 9 pair left over. Now this one here has to be 1, 2, 3, 4, 5, 6. And that's good because you can't have a 5, 6 next to each other, so the 1 has to go in the middle to separate them. Now he's giving us a few things. Now 1, 2, 3, 4. Oops, I've done too many things there. It's only supposed to be those 3. 1, 2, 3, 4, 5, 6, 7, 8. Yes, and 9, yep. Now that can't be a 3. Now once again we've got a 3, 4. They have to be separated, so the 8 has to be in the middle. And we've got a 3, 4 either side. Now that's given us most of this column. So left over we have 2, 4, 5. Now I can't have a 5 on a German whisper line. And 4 on there would mean those two would both have to be 9, so that's a 2. Not a 2, not a 2. So that can be 7, 8, 9, 7, 8, 9. I can't see how to eliminate those yet, but I'll put them in, I guess. 7, 8, 9, 7, 8, 9. Now we've got to have a 1 and a 3, and they can't go there and there. So the 1 and the 3, which are the consecutive numbers for the 2, have to go in those corners. And then that means that is either a 9 or a 7. And that leaves a 6 for here. And that gets, that one's a 5 and that one's a 6. And now you can't have a 5 next to a 4, so that's a 3. And that's a 4. They're not a 5, that's not a 4, and that's now a 1, and that's a 3, and that's a 7. So they're not 7s. Is there anything else I can eliminate? Not that I can see. Oh, the 1's there. That means a 2-4 pair. That's not a 2. So we've got 1, 2. We can still have 1, 2, 3, 4, or 2, 3, 4, 5 there though. But the 5 can't go next to the 6, so that one's got to be a 1. So it's actually 1, 2, 3, 4. And now 1, 2, 3, 4. We've got 5, 7, 8 left to go in here. This line, there's a 2, 4 pair there, so that one's a 9. That's a 2, that's an 8, and that's a 9. That leaves us with just a 7 in that one, and the 5 and the 8 have to go here. You can't have an 8 next to a 9, so the 8 has to go there, and the 5 there. And let's open up another bit of fog. So far, not too tricky. The start was a little bit getting this one over here and recognising that the 6 had to go up in these corners, I suppose. But not too hard, I don't think. Alright, so now here, what can we put in here? That can be a 1, a 2, can't be a 3, can't be a 4 because that would be next to a 3 or a 5. It could be a 6 if that's a 3. No, it can't be a 6 next to the 7. And it can't be an 8, so that can only be a 1 or a 2. So that has to be either 1, 2, or a 2, 1, or a 2, 4. Oh, not a 1, there's a 1 there. Not a 1. Okay, what can we have on this one here? We've got 1, 2, 4, so it could be 3, 7. Next one will be a 6, 4. Can't have 5, 5. We could have 7, 3. And we could have 8, 2. Can't have a 9, 1. There's a 9 there. Now, actually, there's got to be a 2 there, doesn't there? Either that's a 1, 2 or a 2, 4. So there's a 2 there, so that actually can't be a 2, 8. I can't eliminate the other one at this stage though, can I? If that's a 1, 2, that would be a 4 and that would be a 2. If it's a 2, 4, that would be a 2 and that would be a 4. So I don't think I can eliminate that necessarily because that could still be a 4. If that's 2, 4, let me just think about that again. If that's 2, 4, that could be a 2 and that would be a 4. And then it wouldn't be, but if it was a 1, 2, that would be a 4, 2, and that could still be a 4. Yeah, so I can't just get rid of the 4, 6 that way at all. What if, we'll see what's on this Renban line here then. I assume that's here for a reason. There's not many there, but there's quite a few here. 1, 2, 3, there's a 3 there. 1, 2, 3, 4. So that could be a 5, a 6, or a 9. Got 7, 8 there. So that doesn't leave many things. So what can we have up here? A 9 has to have an 8. So you'd have to have 7, 8, 9, and you're not allowed to have a 7 next to an 8. So that 9's not possible. Now if that was a 3, it would have to be 3, 4, 5, and you can't have a 3 next to a 4. So the 3 is not possible. Can't have 4, 5, 6. Does that mean I can't have the 4, 4, 5? I can't have the 4 either then, can I? Unless that's a 3. I could have 3, 4, 5. That could be a 3. If it was 3, 4, 5. Or, now the 7 can't be 7, 6, 5 because they'd be consecutive, but I could have 7, 5, 6. So that could, that could be a 5 and it could be 7, 5, 6. I think that's right. way to eliminate that? I don't think so. I think they're the only options though. 7, because I can't have, oh, no, I can't have 6, 7, 8. Oh, I can't have 4, 3, 5 because I can't have a 3 next to the 4. And I can't have 4, 5, 6 because I can't have a 5 next to the 4. They've all got to be 2 away, so the only way to have a 4, that would have to be a 6. I could have 4, 6, 5, but there's a 6 there. Or 4, 2 something, and there's nothing there, so that can't actually be a 4. And 6, so that means this one can't have a 3 with a 7. That would have to be a 7, 5, 6 is the only thing I can have there. So that's a 7, that's a 5, and that's a 6. I don't think there's any other options that can go there. Couldn't have the 8, 2 because there's a 2 there. Yep, no, that's it. Good. Well, we'll stick with that. That's got to be a 3 now, and that's a 5. This one up here is a 6, and that's a 7. 7 can't go next to an 8. That's got to be a 9, and that's got to be an 8. And that's cleared up the whole board, but no more clues. So now this is where all orthogonal adjacent cells cannot contain consecutive numbers will come into play working out the rest of the Sudoku. So these ones left in here can be 1, 2, 4, 8 or 9. 1, 2, 4, 8, 9. Now what can we eliminate? 3 can't go next to a 2. Is there anything there? Yes, a 2 can't go next to a 3. And a 4 can't go next to a 5. And a 4 can't go next to a 3. That means that's the only spot here for a 4. That's got to be a 4, and that's 2. So that's a 2, and that's a 4. Now it's just going to be a matter of putting all the rest of these numbers in, I think, and seeing what we can do. So I'm going to put these all in the cheaty easy way, like this, and just go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then get rid of the ones that don't suit. So that was 8, 3, 7, 2, 6 along that row, 4, 5 there, 1, 6, 2, 4, 5, 7, 8, 5, 9, 4, 3, 7, 6, 8. Anything out of that we can do? We can, no, 1, that can't go next to a 2, 8 can't go next to a 9, get rid of that 9. The 6 can't go next to a 5, that can't be a 5. The 8 can't go next to the 9. So does that give me anything, any doubles or anything that I can see? No, not yet. Alright, let's go up to this one. This one we can have, I'll do this one. By looking at this one, I can have 1, 8, 2, 3. There's no 3 there. 4, 5, 6, and 7, 8, 9. I think that's all that goes in that one. I'll get rid of them in a minute. 1, 2, 3, 4. That can be 5, 6, 7, 8, 9. This one can be 1, 2, 3. There's no 4 there. 4, 5, 6, 7, 8, and 9. Okay, so I'll get rid of those ones. 1, 3, 6, 7, 2, 8, 9, and 9. Now, is there anything I can eliminate because of the orthogonal rule? Not there, not there. Yes, that one can't be a 6. That one's okay, that one's okay. Didn't miss any? No. Well, that didn't seem to do much either, did it? 8, 9. 6, 5, 7. Can't see any way to get rid of anything there. 8, 9, 9, 6, 8. Is there anything that can only go in one square or something? The 6, 1, 8, 1, 3, 3, 8. Yes, the 6 can only go there in that column. So that's definitely a 6. That means that one's not a 5. So the 5 can still go there or there. 6 can't, actually that can't be a 7 next to a 6. It's not a 7. Now if that's an 8 or a 9, if that's an 8, it can't be a 9 because it's next to it. If it's a 9, it can't be a 9, so that can't be a 9. And if that's an 8, it can't be an 8, and if it's a 9, it can't be an 8, so that one's a 5. And that's a 7. Now 5 can't go next to a 4. Anything else there? Got a 1, 9 pair in there now, so that one's not a 9. And that one's not a 1. And that did help a bit. Now what have we got? 8, 9, 8. The 8 can go there or there. The 9 can go there or there. There's no other singles, is there? 1, 3 can go there or there. Can't see any other singles there. Alright, we'll put these ones in and see what we've got. I'll do the same as what I did before, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we'll get rid of the 3, 1, 6 along there. 4, 5, 7, 8. Get rid of 7, 2, 6, 5. And 4 and 8. And get rid of 7, 8, 9 along there. 6 and 4, 5. Now look for things. So 5 can't go next to a 6. And get rid of that 6. And there's nothing there. 7 can't go next to an 8. 3 can't go next to a 2 or a 4. And that's all. Now what does it left us with? Anything good? 2, 4. 1, 3, 8, 1, 9. 1, 2, 3, 4, 5. 1, 2, 3, but there's 5 things. What else? Oh, this one up here should have got resolved way earlier. There's a 4. You can't have a 4 next to a 3. That's got to be a 5 up to there. It's got to be a 5, and that's got to be a 4. So that's a 2. Gets rid of all the 2's along there. And that's not a 4, that's not a 4, that's not a 5, that's not a 5. Now we've got a 1, 3. Oh, there's another one up here. That one's a 4. 1, 3, 8, 1, 9, but we've got a 1, 3 pair here, so that has to be a 5. And that has to be a 6. And that's not a 4. Now, we're going to change things. We've got to check each time. That one can't be a 4 now. Next to the 5. 6 can't be a 5 or a 7. That doesn't change anything. Anything here. 1 can't go next to a 2. That's got to be a 9. That's an 8. Resolve these ones down here. That's not an 8. And that's not a 9. And that's not an 8. Oh, and the whole heap down here as well now. 4, 9, 5. Not a 9, and whoops, different ones. That one's not an 8, and that one's not a 6. Now I just realised we've got a 3, 7, 8 here. The 7, 8 can't go next to each other, so the 3 has to go in between them, doesn't it? And we've got a 3, 8 pair there now anyway, so that's a 7, which means that's got to be the 3 between them, and that's got to be the 8. 1, 2, 6. You can't have a 1, 2 next to each other, so that's got to be a 6. That's 1, that's a 3, 2. So if you remember that rule, it's not that difficult. So 1, that's a 3, that's an 8, and that's a 4. 1, 9, 2, 3, and 2, 1. And done. There you go. Yeah, so it started out a little bit difficult getting this first bit perhaps, but after that Wasn't too bad really, I don't think. Anyway, I hope you didn't find it too hard and enjoyed that one. And I'll see you on the next one.